Recall that for differentiable function y equals f of x, the derivative is defined as f prime of x, which is the same as dy over dx, is the limit as delta of x goes to 0, f of x plus delta of x minus f of x all over delta of x. Delta of x meaning the change in x. Okay, so delta of x, this means the change in x. So just like x minus c in this sense. And it's the same as limit as delta of x approach 0. So this is y1 minus y2, right? So it's change in y divided by change in x. And that's why it is related to the slope, right? Rise over run, right? Change in y over change in x. So f of x, okay, so because of the limit definition, so without the limit, we can saying, okay, it's just approximately delta of y divided by delta of x. And as delta of x getting smaller and smaller, closer and closer to x, this quotient is closer to the derivative. And that's why it's related to the slope. Because delta of x is non-zero, we can multiply both sides of delta of x to solve for the change in y. So the change in y is approximately f prime of x times delta of x. And sometimes you see f prime of x, delta of x, what it means is a multiplication. And based on this, we can derive the formula for the differential. So the differential of x, and it is important when we study integral. Okay, so memorize this definition. The differential of x is denoted by dx, and dx is the same as delta of x. So this triangle is pronounced delta. The differential of y is dy. Okay, so it's different from delta of y. This delta y is just an approximation, but this one is exact. So dy exactly is f prime of x dx. So how do we apply differential? Let's take a look. Example 2. We use differentials to approximate the change in volume of a spherical balloon of radius 8 meter as a balloon swells to radius 8.2 meter. So we want to approximate the change in volume. What is the change in volume? Change in volume. And we are approximating, right? So according to this formula, approximation, delta in the volume, change in the volume is approximately f prime of x, so the derivative at x times the change in x. Okay, so what is a derivative? So first of all, the volume formula for a spherical balloon, right? For sphere is 4 over 3 pi r cubed, or pi x cubed in this case, because we're using the variable x. So v prime of x is, so what's the derivative with respect to x? We keep the constant 4 over 3 pi, right? Then we multiply by derivative of x cubed. So it's 3x squared. So the v prime is basically, so cancel the 3, is 4 pi times x squared. Now what is x in this case? X is 8 meter, okay? But then what is the change in x? Well, the change in x is from 8 meter to 8.2 meter. So what is the change? 8 to 8.2 is 8.2 subtract 8, which is 0.2 meter. So is equal, okay, f prime of x, v prime of x, so it's 4 pi times x. What is x in this case? Is 8 squared, okay, times delta of x is 0.2. So you can use a calculator, okay. This number is 51.2 pi. So that will be the change in the volume.